Identifying and representing functions. What defines a function and how can it be represented? Well, let's take a look at some definitions first. We know a relation is a set of ordered pairs. And if we thought of a function machine or as a rule or an equation, we can take a look at an input going into that machine and then an output coming out. We can call that input an x value and our output would be a y value. So let's take a look at maybe how this might work. Let's say that I put a 2 into the machine and on the other side as an output, out came a 4. I put a 3 and out came a 5. I put a 4 and out came a 6. We notice that the rule or what's going on is inside here we are adding 2. Every time I put an input in, it adds 2. It takes me to the next number. Let's try a different one. This time, let me put a 2 in, and out will pop a 6. Put a 3 in, out pops a 9. Put a 4 in, out pops a 12. When we see this, we know that the rule is that things are getting multiplied by 3. The input value goes in, gets multiplied by 3, and we're going to get an output value. We can do it once again by taking numbers like 100, putting it into the box and getting 50, taking 80, putting it through the function box and getting 40, and taking 60, putting it through the function box and getting 30. In this case, we can see that the box, what it's doing is dividing by 2, taking an x value, an input, putting it through the function, dividing it by 2, and giving us a y value. We know that we can create equations with this. For example, the equation for this green one would be x, the input value, plus 2 would equal the output value. X plus 2 equals y. This blue one here would be taking the input x, multiplying it times 3, and that would give us y. And this other one on the end here, this black one, it's take whatever value of x is, divide it by 2, and that's going to equal y. So here we have our equations or our rules to help us decide if how something functions or not. Now, we know that a function is an equation where the input has a one-to-one relationship with the output. In other words, one thing goes in, one thing goes out. That's what function means it works. If we put one thing in and 3 things came out, we know it's not functioning or it's not working. For example, if I put a 3 in and out came a 0, a 4 in, out came a 0, a 5 in, out came a 0. Now we may think this is not a one-to-one relationship, but it is, because what's going on inside this function box is whatever it's taking, whatever that x value is, multiplied by 0, we're getting an output value. So there still is a rule there. But what I'm saying where it's not a one-to-one function is, let's say you put the number 2 in, and then all of a sudden out pop numbers 3, 5, and 7. Well, 3 numbers popped out when 1 number went in. It's not a one-to-one relationship, so that's not a function. Okay, so let's take a look at some through mapping diagrams. You're going to need to be able to use mapping diagrams as well as other forms to be able to tell if something's a function or not a function. So we'll take a look at this first. So here we have input A, and out comes 1. Input B, the output is 1. Input C, outputs 2. Now, at first we might think that this is not a function because both of these are going, A and B are both going to 1, but they're only having one output. So as long as there's only one output, yes, it's a function. And remember, we have to say why something is a function. It's a function because it has a one-to-one relationship. So we can see that and we know that that's what's going on. Okay? Let's take a look at another one here. Here in this example, we have an input of A, and this input of A has an output of 1 and 2. The input of B has an output of 1, and the input of C, the input of C has an output of 2. So because of this, we can see with the A with 2 outputs coming out of 1 input that this is not a function. Because it does not show a one-to-one relationship. So remember, we've got to be keeping about our reasons and thinking our reasons out loud. okay, and knowing what's going on. Let's take a look at one more mapping diagram. This time, this one looks a little bit different in that we've not had the words input and output, but always know that the one on the left is the input and the one on the right is the output. So we have these numbers 1, 3, 5, and 7. We have the number 1 input, one number comes out, 2. We have the 3 as an input, 4 is the output. 5 is the input, 4 is the output. 7 is the input, 6 is the output. And again, there is a one-to-one structure there, so this is a function. And it's 1. I'm going to say because it shows a one-to-one relationship. Okay? All right, so hopefully that explains a little bit. Now, we're going to see it whether something is a function 4 different ways. First, we looked at it through mapping diagrams. Now we're going to take a look at tables. Now, tables is another way we can look at things. And here we have a table. We have 3, 0, and 5, and negative 4, 2, and 1 are our y values. We have to remember that our x represents our input. And that y, I'm sorry about that, guys. Keep hitting the wrong button here. And y represents our output. Now, with that knowledge, we can look at these numbers and know 3, negative 4, 0, 2, 5, 1. We can see that it is a function because it shows a one-to-one relationship. Okay. Now, we'll talk about how it works in a graph in a second, but I do want to show you as ordered pairs as well. If I sat here and wrote the ordered pairs out, just like this, it's the same as doing the table. We would look at the x values, and once we take a look at those x values, we would say that there's nothing here repeating, so we don't have to worry about it. They're single, they're different, so therefore it's going to be a function. They're having different values there. We'll come back to the graph in a second, as I said. We're going to go to the next slide here. Here we have in this example, by table, we have a negative 3 as an input, but it's a negative 3 every time. And the output's 2, 5, and 7. In other words, we're putting one thing in and 3 things are coming out. And because of this, this is not a function because it does not show a one-to-one relationship. Okay? Now, we're going to talk about vertical line tests because this is important. If we're doing it by graph, we can look at the vertical line test to see if it's a function or not. We don't necessarily have to double check and see if it has a one-to-one relationship. So let's go back here to our example number 4, and let's plot these points on our graph. So we have positive 3, negative 4. We have positive, 0, positive 2, and positive 5, positive 1. So here we have these 3 points. At first it might look like a triangle, but it's not, and it's definitely not a line, but it is a parabola, and I will show you that in a second. Now what we're going to do is take our line, which here we have our line to do our vertical line test, and we're going to pass it through these points. Now we notice that it only touches one point at a time. If it touches one point at a time, then that means it passed the vertical line test. You can take your pencil and hold it vertically and roll it across your paper. If it only touches it in one place, then you know that this is a function. So we can add to this that it's a function because it shows a one-to-one relationship and because it passes the vertical line test. Okay? Now, we can take a look at this. Remember I said here a moment ago that this is a parabola. It would look something like this side going up here, and then this side coming up like that a little bit. Hopefully a little bit better on the drawing than I am. There we go. Something like that. And our parabola would come through these points like that. And you can see that as it goes through the parabola, it's only going to touch it in one spot only. So that's why parabolas are functions. Okay, let's take a look at this example 5 and let's plot these points at negative 3, positive 2, and at positive 5 and positive 7. If we took that vertical line test and we can see, boom, it's touching all 3 at the same time. So this does not show a one-to-one relationship, or should say and, it does not pass the vertical line test. So let's take a look at some graphs here really quick and talk about the vertical line test. Let me change our properties a little bit on this line and make it really thin, because that'll make it easier for us to look at some curves. Because sometimes when you see a curve and you use a fat line, you say, well, it touches in more than one spot. But you can see as we go really slow here, even as it starts to descend a little bit, it's only touching that line in one spot. It's not touching it in any other spot. So this curve right here does pass the vertical line test. Here I have an oval, and an oval can also be used, you can write an equation for an oval, and we can see that it touches it in more than one place. Right here at top and bottom, it touches it in two places. Therefore, this is not a function. We're a little more familiar with lines because we've been talking about that for a while, and we can see that this is only going to touch it in one spot at a time. And since it does that, we know that these linear functions, or these linear equations, happen to be functions. We have a couple other curves here. One, it represents an exponential function, actually a half-life, as we can see it decreasing quickly and then descending here. And here we have a half of a parabola. And again, it's only running into it one place at a time. I'm going to add a couple of lines to that linear one up there just so we can have a little bit of a discussion. We'll put them in purple just for some fun. Okay, let's put a line through here. And we'll put one straight up and down there. And then I'll take one up that direction. Okay, that way we can talk about lines for a second, because we've been talking about lines for quite a while at this point. So this line going downhill here, we know y equals negative x. It's dropping by 1, and it's crossing at 2. This purple one that I did right here, this seems to be going uphill. It is going uphill, so we're going to call this x plus 1. This one here, y equals, and we would say normally just y equals -4, but I'm going to put the slope in there so that we can all talk about that. That's 0x, because 0 times x is 0, minus 4. You'll notice that all three of these, that black one and these two purple ones, all have a slope. And they all have a slope. This has a -1, this is a +1, this is a 0. Those are all numbers. They all have slopes and they all have y's in them. Now if they have a y, they must have a slope. And if we take our line here and we pass it through, we can see that it's going to pass through them all individually and that all of those are functions. But what happens when it touches this one over here? It pretty much disappears, doesn't it? It goes behind it because the line or the equation for this function happens to be x equals 6. And we also know that this has no slope. It's undefined. So again, no slope, not a function. No y, not a function. So there's some things that help us to see a function also from a equation point of view. So we know that how to find a function then now by using mapping diagrams, by using ordered pairs, by using tables, and by using graphs. Hopefully this helps you in identifying functions.